Good morning, everybody. Happy Wednesday. How you guys doing? Homework's due tonight. Seems like some things are making sense for people, some things aren't making sense for people. I think there's a lot of helpful information on Discord from yesterday. Good morning, Joey. It's Wednesday. Homework document. Okay, so I was just pulling up the homework document. I figured this video is being recorded. Why not help out a little bit? Notes. There we go. So since no one's really chatting, which is fine, let me give some hints on the homework based on some just emails I've gotten, seeing what people are chatting about on Discord. So for problem 1, morning other Joey. For problem 1, so you've got your file, you have the states in column 1, the pressure in column 2, and the temperature in column 3. I'm pretty sure that's the order. The states are just 1, 2, 3, 4, 5. You can think about it as like samples. If states doesn't work for you, think about it in terms of samples. Maybe that might make more sense. So you do this calculation with your temperature. Note you have T in there. Oops, there's no T there. And then you just compare. You have your pressure with your calculation. Remember, for this one, you need to compare it in 2 pieces. So you need to compare this first, and then compare this, and then you're going to combine it with an and and an or. You can't just type this expression, whole thing, the way you see it, because that's not how order of operations works. Okay, so make sure you do 2 questions, one with that group, one with this group, and then combine it. Okay, that's your main piece. Then you just need to count. So when you compare things, you're going to get an array of answers, of logical values, of 1s and 0s. So you need to count them. So here you're going to count the 1s that you get. So there's ways you can do that. I talked about that in lecture. And then this one, you need to identify which states, which samples correspond to where there's a 1. From there. Okay, so you'll use logical indexing. It's not how you spell logical. And there's been a lot stated on that on Discord. Okay, so that's the general flow. There's a couple ways you can do figure out this number, but that's what you're gonna do for that problem. For the second problem, so I fixed this, so you guys should see the correct comparison. Told you guys I'm terrible at them, so thank you to whoever noted and mentioned and told me to correct it twice. So this one's pretty straightforward. You just compare the weight to see if it's less than 1 pound. Remember, your weight is going to be passed in as an array, where the first number is in pounds, the second number is in ounces. So 3 pounds, 12 ounces, 4 pounds, 7 ounces, 1 pound, 2 ounces, 0 pounds, 3 ounces. So it's going to be passed in as a vector. This is your first number, this is your second number. So use those numbers appropriately. Which one do you need for which situation? And then it says for every additional half pound past 1 pound, or every pound past 5 pounds, you need to come up with a way to do this. So use these examples. Let me do one more. 7 pounds, 2 ounces. So use a couple examples, do it by hand. So this one is 3 pounds, 12 ounces. So it's going to be 2 pounds past 1 pound, and then another half pound. So this is going to be a total of 1, 2, 3, 4, 5 half pounds. Here we've got 3 pounds past 1 pound plus 0 half pounds. So we've got 6 half pounds. So come up with some examples. Here we have 0 pounds 0 pounds past 1 pound plus 0 half pounds. So this one essentially is just 1 pound. Here it's less than 1 pound, and here we have 2 pounds past 5 pounds. So come up with some examples. Come up with some way of how you calculate it, how you figure out in your head. It should be the same process every single time. And that's what you're going to do in order to come up with an algorithm, in order to come up with a way to calculate it. So note it's 2 pounds past 1 pound. How do I know it's 2 pounds past 1 pound? Because it's 3 minus 1. And then 1 half pound. How do I know it's 1 half pound? Because of my ounces. So you don't have to use the floor function. You can. You don't have to. But just come up with a way of how do you calculate it in your head? How would you know that it's how many pounds past 5 pounds, or how many half pounds past 1 pound? And that essentially gives you an indicator of how can you calculate it every single time. Let's see, for problem 3, it's really just be careful with your numbers here. There were some issues on MATLAB Grader of it being correct sometimes and not correct other times. And the only thing I can think of, the reason why that would happen is because of some very small rounding errors. So your threshold for your homeworks, really your answer needs to be within, it's either 4 zeros or 5, or it's either 3 zeros or 4 zeros. So here's our threshold that we use in order to see whether or not your answers are correct to account for algorithm errors or algorithm differences. So it's not a very small number. It's not like 10 e to the negative 10. It's only 10 e to the negative 5. So if you have one of these numbers missing, one of these numbers is typed in incorrectly, so it's incorrect, then if it's a small enough error, say if you're missing this 9 here, notice it's in the 10 to the negative 5th position, so that might cause rounding errors in some answers, but not in others, depending on the random numbers that are generated for your MATLAB Grader problem. Okay, so just make sure you have those numbers typed in correctly. Okay, so that took up more time than I wanted, but that's okay. So let's go ahead and continue talking about loops. Good morning, Matt. JR, I'm glad you found number 2 oddly, or number 2 or 1, I can't remember when you typed that. Fun to do. It's always, I don't know about you guys, but whenever you like figure something out with a program and like it works and you're like, oh my gosh, it's amazing, I did it, this is awesome. I don't know, I just find it oddly rewarding. Okay, so on Monday, we wrote a couple loops. We wrote some basic counting loops using while and for. Someone asked if I here can be created before your program, and that's totally fine. This is literally an assignment statement. So it doesn't matter if I previously stored a value of 10. That doesn't matter. I is going to be just reassigned. So it's going to be reassigned to a -10, and then reassigned to a, for this one, -5, and then reassigned to a 1. So it doesn't matter where your variables exist before. The important thing is for a while loop, though, is that num, your variable that you're testing, needs to be initialized before your loop. Whereas with a for loop, it doesn't really matter if this variable is created beforehand or not, because it's just going to be reassigned with this expression. JR, no, I completely understand. I was writing some code for the linear algebra portion of the class, actually, and I used some techniques I've never used before with programming, and I was so excited. I was like, someone needs to know that I did this. It was amazing. Okay, we also wrote some loops down here that essentially run through this process, where we have an algorithm to calculate the cube root of a number. And this was our algorithm. Essentially, choose an initial guess, create a new guess, calculate the error, and then repeat. Okay, so this would be our repeat. So we could rewrite this algorithm and say the word repeat until something. So a lot of times in your homework document, if you see the word repeat, that means use a loop. Repeat, do something over and over and over again until some condition is false. Okay, just like when you see the word prompt, it means input function. When you see the word repeat, it means loops. Or if you see the word while, that means while. Okay, so let's write some more loops, and then I am going to try and go through this relatively quickly. Because I really want to get to your homework document and explain some tips for homework 7, just because loops do tend to be more challenging in order to put together the algorithm and figure out what you're trying to do, take the description on paper and put it into code. Okay, so the first example for today I want to do is write a loop that sums up all the odd numbers in an array. So let's say I have my a value, rand I, -10, 10, and then let's say I have 10 numbers. Okay, so let's say this is what a looks like. I can find all the odd numbers by just saying a, okay, how do you do odd? I know how to do it with mod function. So, mod a, comma 2 equals 1. Yeah, so this is one of the ways to find odd numbers. It's not the only way, but it gives me a logical array, and there's a 1 wherever it's odd and a 0 wherever it's even. And I could do this without loops, but I want to use it as an illustration. Okay, so this is how I'm going to use to figure out if a number is odd. Okay, so I'm going to just pin that for a minute. Okay, so here's my array of a bunch of numbers. If I want to sum up a bunch of numbers, essentially what I can do is essentially go through one number at a time. So is the first number odd? So with a 1, 1 odd. If it is, then add it to my sum. If it's not, then I'm going to skip over it. And then I'm going to go on to the second number. Same thing. If my second number is odd. If it's yes, add it to my sum. If it's not, skip it. And then same thing, if my third number is odd, add it to my sum. If it's not, skip it. If it's my fourth number is odd, add it to my sum. If not, skip it. So that's the whole process. So I can just rewrite it to say that it's for I equals 1 to the length of a. And I can check to see if each number is odd. If a mod a I, comma 2 equals 1, I'm going to display odd number. Here I'm just demonstrating how to use disp again. Yeah, so here's that conditional that I mentioned down here. This is one of the ways to find an odd number. It's not the only way. I've shown you guys how to find an even number using the round function. But mod is something we haven't gone over. You can also use the remainder function. That's the one way that goes off the top of my head, so I'm not gonna look up to see how I did it differently. Okay, so let me run this. Okay, so here's my A for this one. It's a different A because it's random. And it goes through one at a time, and I can see I printed out all the odd numbers. There's actually a decent number of odd numbers. Okay? So I've done this. I've checked to see if they're odd. That's great. I did it with an if statement, or with a for loop, that just iterates through all of the values in A for I equals 1 to the length of A. So now A is 1, or I is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be one of those numbers each time. First it's 1, then it's 2, then it's 3, then it's 4. And then here I'm checking to see if it's odd. I'm checking each number, so I need to say AI. Because it's not all of A anymore. It's just each number individually. So it's the first number, then the second number, then the third number, then the fourth number. And I'm just displaying it if it's odd. Now I want to add all these numbers together. When you do a summation of a bunch of numbers in a loop, this is our process. We initialize our sum to 0. This goes before our loop. Okay, this is the first thing we do. So here's our process to add a bunch of numbers in a loop, which you will do this many, many times for your homework and for your project. So first things first, initialize a sum to 0. I'm going to call my sum S. Don't call your sum because the sum function is named sum. Okay? So just keep that in mind. I'm going to initialize my sum to 0. And then inside of our loop, we say S equals S plus our new term. Add next term to sum. Okay, this is inside our loop. And that's it. Okay, so when we're adding a bunch of numbers, when we are doing a summation, here's our process. We initialize our sum to 0. And then inside of our loop, we say S equals S plus our new number. So if my number is odd, I'm going to say S equals S plus my new number, which in this instance, my new number is just whatever that value in A is. So now, I'm going to use the fprintf function just because it's easier. So fprintf, I'm going to list out AI. AI equals my number. Sum equals my number. One note, when you're working with loops, it's very important that you have fprintf and display for debugging purposes. With if statements, with anything else, you can pretty much step through with the debugger and it's not going to be that big of a deal, or you can follow through with your pencil, essentially identifying which line of code is being executed. For loops, though, it repeats so many times, it's just tedious to use the debugger. So typically we use print statements. So I need to stop saying so. So on Monday, notice I put these print statements in here. I put fprintf. I printed out our guess and our error for both of these loops. Okay, that's a good indicator that you are checking what your answer is every single time you go through your loop. So every single time this is calculated and every single time this is calculated, I'm going to print out my result just to see what's happening. Same thing here. I'm going to print out my value of A, make sure I'm getting all of the odd numbers, and I'm going to print out my sum to see what's happening. So A of I, and S. Okay, so now I'm gonna run it. It's not aligned beautiful, so I'll just align it just for kicks and giggles. Okay, so here it's nicely aligned. So here's my A values. So in theory, I should be summing the -7, the 1, the -7, the -5, the 3, and the 5. Okay, so all of those locations. So now I can see if my loop actually did that. So A of 1 was -7. That's odd. Yep, got that. Check. So my sum is -7. It's going to be 0 plus -7. And then A of 4 is 1. That's my next odd number. So that's great. That's check. My sum is -6. It was -7, and now I added my 1. And then A5 is my next odd number, which is -7. So now my sum is -13. It was -6. Now it's adding -7 to give me -13. My next odd number is -5. So my sum was -13. Now it's -18. My next odd number is A8. My sum was -18. Now it's -15. Because -18 plus 3 is -15. And then my next odd number is my 10th location. My sum was -15. Now it's -10. And so when we're doing it's called a running sum, when we are adding a bunch of values together, we are starting out our sum at 0, because 0 plus anything is anything. So we're adding the first number, and then the second number, and then the third number, and then the fourth number, and then the fifth number, and then the sixth number. So this is the long way to do this in MATLAB, but this is important because you'll see a lot of calculations that look like this, where it says the value of pi can be estimated from the following equation. And then it says pi cubed over 32 equals this huge sigma, and then this term. So this is adding a bunch of numbers together. You guys should know that. You probably have seen this in math. You should have seen this at the end of Calc 1. If you're in Calc 2 right now, you're probably just being like, no, not in 230 as well, stay away. But don't worry, we're not doing sequences and series in here. We are just using this as an indicator that we are summing up a bunch of numbers. Okay, so what does this look like? I have a for loop as just a start. So it's literally, I'm just gonna do the same thing I did up here. So I'm gonna choose n, because n is used in here. N and n and n. I'm going to say for n equals 0, because 0 is my first number here. So that's where I'm starting. For n equals 0, all the way until infinity. Remember, that's our notation. Sum up all of these numbers where n starts at 0 and then n goes to infinity. We don't have infinity. I don't want to go until infinity. So I'm just going to choose 10 for now. I'm just going to start with some number. 10's a pretty good number because you can check to see how your code is doing without it taking forever or producing a whole bunch of like 100 numbers to print out in your command window. For n equals 0 to n equals infinity. And then I'm just summing a bunch of values, right? I'm summing -1 to the 0 over 2 times 0 plus 1 cubed plus -1 to the 1 over 2 to the 1 plus 1 cubed plus -1 squared over 2 times 2 plus 1 cubed plus ... So this is what I am summing up. So I'm going to start my sum at 0, because that's my first step. Start my sum at 0. And then inside of my loop, I'm going to say sum equals sum plus my new term. In this instance, my new term is going to be this calculation with my new value of n. So it's going to be -1 raised to the n divided by 2 times n plus 1, the quantity cubed. So this is my new term. I'm just summing up a bunch of these numbers where n starts at 0, and then n goes to 1, and then n goes to 2, and then n goes to 3, n goes to 4, etc. So I set up my loop that does this. I start my sum at 0, and then here I just say for n equals all of these numbers. calculate this new term and sum them all together. So let's go ahead and print some stuff out. So fprintf, I'm going to print out my new term. I'm going to print out n equals %2d. My new term, I'll just call it n equals percent, it's probably 5.3f. It's probably a floating point number. And then my sum equals 5.3f. We'll start there, see what happens. So n, new term, and s. Okay, so fprintf statements, very useful. You can print out all of the pieces and see how your loop is moving. Okay, I didn't quite get my spacing right, but that's okay. So here we go. We can see how things are changing. So here's with n equals 0. Here's my first term. N is 1. So now my sum is 1. And then it goes to 1. Here's my new term. So my new sum is whatever it was before plus this number. And then we can keep going. Notice my new term is pretty small. Let me print out more digits past the decimal place. Just to see what's happening. So here we go. So more digits past the decimal place. We can see that my sum didn't really change much, only printing out 3 digits. But we can see it is still changing. It's changing out at the further digits. Same thing with my new term. My new term is getting smaller and smaller and smaller, which makes sense. So what happens if I go to 20 terms? So start to change it. What happens if you go to 20 terms? What happens if we change this to a while loop? So what if I say while? And let's say I want to stop when my new term gets really small. So while my new term, so I want to stop. So let me put a note up here. I want to stop when my new term is less than 10 to the negative 5. So I want to stop something when there's 5 digits past, or when there's a bunch of zeros here. So that means I want to continue. So I want to continue while my new term is greater than 10e to the negative 5. So notice this is when I want to stop, which means this is when I want to continue. These are opposites of each other. I could do equals to, it's not going to make that big of a difference. So stopping, continuing. So let's run and see what this happens. Okay, notice new term is now my loop control variable. So here it says unrecognized function or variable new term. That means I forgot to initialize it. So I'm just going to initialize my new term to something. It's not going to make a difference of what it is because it's going to automatically be reassigned here. Okay, so let's try it again. Okay, so now it says unrecognized function or variable n. I took out my for n equals 0 to 10. So now I just need an additional variable. So n starts at 0. And then here I just need to say n equals n plus 1. So it still has all the pieces. They're just different. My conditional, I'm not going for a specified number of terms now. I'm changing it. Okay, but I still need all the pieces. So just listen to the errors that MATLAB gives you to give you an indicator of what you're missing. Here for this first error, I was missing an initialization for new term. For this second one, I just took out n and I forgot to recreate it. So here we go. So notice it only prints out 2 digits or 2 iterations. It prints out where n equals 0 and n equals 1. And I notice, okay, previously I had a lot more printed out, and I know that n goes, like, n is clearly not less than my tolerance. However, I totally forgot about the negative sign. If you forget about the negative sign, you're typically remembering, oh, it should be absolute value. So piece it together one at a time. Try and understand what is happening inside of this loop. The key piece is this stuff is being repeated over and over again, and some of this just comes with practice. Yeah, but this is what a summation looks like. There's lots of ways you can do a summation. This is one of them. You can do it with a for loop like we did up here and down here. You can do it for a certain number of terms. You can do it until a certain condition is met. You can even do it both ways. So let's say I reduce this to 10 e to the negative 10. It goes out to 500. N goes out to 500. That's a lot of terms to scroll through. Notice it didn't take very long to do that. So your computer is fine. It's going to process lots of data really quickly if it's small data. But let's say I don't want to go out to 500 terms. Let's say I want to continue. I want to stop when my new term is less than 10 e to the negative 10, or if the number of terms, so n, counting the number of terms, is greater than, let's say I want to do greater than 100. So now I have two stopping conditions. If my new term is less than a certain number, or if I've reached the number of iterations and I just want to stop. I just want to be like, you know what? I don't need 500 iterations. At most, I need 100. So this is when I'm stopping. Invert that to figure out when you're going to continue. So the opposite of n greater than 100 is n less than or equal to 100. The opposite of or is and. So now it's going to stop while my new term, so now it's going to continue while my new term is greater than my threshold, and if my number of iterations is less than or equal to 100. So there we go. So now it stopped, even though I hadn't reached my threshold yet. I stopped when I reached 100 terms. So our while loops are a little bit more flexible in terms of when we're going to stop. A for loop is much more rigid. It's just going to go for however many numbers there are in the array. A while loop, we can have multiple conditions to stop things on. Okay, but that's our process for adding numbers together. Initialize your sum to 0, and then s equals s plus our new value. You'll see this a lot. Notice this is our summation notation. Capital sigma. Whenever you see a capital sigma, that means you need at least one for loop. Depending on what your calculation is, you might need more than one for loop, but a capital sigma means you need a loop. You're going to iterate and sum through a bunch of numbers. This is our process. Okay, I want to go over one last example before I talk about the homework. So let's say, there we go, it's a little small, very small for you guys. I'll zoom in. So let's say I want to recreate this matrix. So A is a matrix. It's mostly zeros, except in rows 1, 2, 3, 4, 5, 6, 7, 8, 9. In rows 2 through 9, no, 2 through 8, should be a 10 by 10. It's a 10 by 10. I just can't write small enough, apparently. Rows 2 through 9, I have 1, 2, 3 that show up. And it's staggered. Okay, so first things first, if you're trying to create a matrix, type out what you're trying to do. So A is a bunch of zeros, so I'm going to start with A being zeros. Like I said, it's a 10 by 10. So 10 rows, 10 columns. I could also just type zeros 10. So I'm initializing A with a bunch of zeros. And then I want to change A. So I'm going to write out what is actually changing on paper. So A, row 2, columns 1 through 3 are set equal to 1, 2, 3. In row 3, so row 3, columns 2 through 4 also equal to 1, 2, 3. In my next one, I'm in row 4 now. And then here, it's columns 3, 4, 5. 1, 2, 3. Keep going. A5. It's going to be 1, 2, 3, 4, 5, 6. Okay. Eventually, you should come up with some sort of pattern. Same way we talked about with the handling arrays, was a homework 3, I think, when we talked about corners in class. You have to come up with some sort of pattern. So notice we have 2, 3, 4, 5. So it's just iterating, starting at 2, it's going to end at 9. 2, 3, 4, 5, 6, 7, 8, 9. So let's start there. So 4i equals 2 through 9. I'm doing something with rows 2 through 9. Okay? Every time this is the same. So it's always equal to 1, 2, 3. And then figuring out what goes here, what columns. So notice if it's 2, then it's 1, 3, 2, 4, 3, 5, 4. So every time this first number is going to be 1 less than this number. So I'll put a comment. My first column is I minus 1. My first column is I minus 1. And then this last column, 3, 4, 5, 6. If it's 2, 3, 4, 5, this is 3, 4, 5, 6. So this first number here, this number here was I minus 1. This last number here is I plus 1. So that means it's always going to be row I, column I minus 1 to column I plus 1. It's always equal to 1, 2, 3. So this is one way of how we can fill this array. So if I clear my workspace, I need to display A. There we go. So now it's A. I filled in each column according to the rows, or I filled in each row according to the correct columns. So this first number, A of row 2, column 1 to 3, this first number is I minus 1, is 2 minus 1, and this second number is I plus 1, so 2 plus 1. Here is 3 minus 1 to 3 plus 1. 4 minus 1 to 4 plus 1. 5 minus 1 to 5 plus 1. So it's always minus 1 to plus 1. So this is one way to do it. Another way we can do this is using nested loops. So A is still 0s, 10, comma 10. 4i equals 2 through 9. So this is going through the rows. We could also do this with nested loops. Okay, we don't have to, like I just said, but I want to use this to illustrate nested loops. So if you're ever running into a situation where it's not always the same numbers, or these numbers are not predictable in some way, shape, or form, where it's not just always 1, 2, 3, we can use nested loops. So we use one loop to go through the rows, and then we can use another loop to go through the columns. So it would be I minus 1 to I plus 1. So this does the same thing. Rather than doing it all at once, using our fancy MATLAB notation, I can do it one number at a time. Say A, I, comma, J. So go through the columns. And a lot of times this is what you do. A lot of times this is what you do for matrices. If you have a two-dimensional array, you use one loop to go through the rows, and then a second loop to go through columns. Or the other way around. It doesn't matter. And you can do the other way around. You don't always have to, because MATLAB allows us to do multiple accessing and multiple modification all at once. But you can use nested loops. So for I equals 2 through 9. So given a single I value, J is going to go through all of these. So the key piece when it comes to nested loops is for every single I value, all of the code inside of here is going to be executed to completion. So for I equals 2, it's going to go through all the J values. For I equals 3, it's going to go through all the J values. For I equals 4, it's going to go through all the J values. So this inner loop is going to be repeated completely as many I values as there are. And then, I don't know, it would be, I'll just say I right now. So this one's not going to be exactly the same, because I'm just filling it with the row. But for I equals 2, J is going to go from 1 to 3. So it puts a 2 here, a 2 here, and a 2 here. For I equals 3, J is going to be 2 through 4. So 3, 2, 3, 3, 3, 4. For I is 4, J is going to go through 3 through 5. So 4, 3, 4, 4, 4, 5. So these are two ways to do the same thing. In general, in MATLAB, the rule is try to not use loops as much as possible. Sometimes we can't avoid them, sometimes we can. In this instance, we could avoid the nested loop, and we did not have to do it like this. And that's just because MATLAB is optimized to index through arrays without using loops. That's why we have element by element notation. That's why we can do this multiple indexing, multiple accessing, multiple modification. So in general, avoid loops when you can, but you're not always able to avoid loops. Sometimes you have to do it this way, depending on what your variables are. Okay, but this is what a nested loops looks like. This up here, the first one, we had nested structures as well. We just had an if statement inside a for loop. So notice any valid code can go inside of a loop. Just keep in mind, everything inside of here is going to be executed. It's like its own mini program before it goes back up and chooses the next value for I. Same thing inside a while loop. You can have any valid code inside of a while loop. Just notice it's another mini program. It's going to be executed completely before it goes back up and checks your conditional. So for this one, we have our own mini program in here. So for I equals 2, it's going to complete that mini program before it goes up and chooses another side of another value of I. So JR, yes, loops inside of loops are confusing. That's why it's important that we print things out. So I mentioned in the notes, week 7. I mentioned in the notes, where is it? There's this, give me a second. There's this example that I mentioned in the notes where best practice is to use print statements, so fprintf or display, to print out the values of important variables at each iteration in order to help debug our loops. So common values to print out would be our loop control or loop index variable. So this would be print out your I values, print out your J values. So for the example with the nested loops, inside of your second for loop, inside of this for loop here, print out fprintf your I values, so I equals %d, J equals %d. So print everything out. So you can see how your values change. So here we can see that I is 2, J is 1, 2, 3. I is 3, J is 2, 3, 4. I is 4, J is 3, 4, 5. So print out your loop index variables. Print out new term here. So we printed out n and new term, because new term was our loop control variable. N here is also a loop control variable. Another thing to print out is the results of our conditional statements. I like to use this for debugging just to make sure that my conditional statement is correct. So this would be for a while loop or for any if statements that you have inside of a loop. So once again, going back to MATLAB, you could print out the result of what is this actually saying. Notice we had the absolute value statement. If the absolute value doesn't jump out in your mind, print out what does it mean to say new term greater than or equal to 10 e to the negative 10. What is it? Is it behaving the way that I think it's behaving? What does it mean to have and in here? Is it behaving the way I think it's behaving? So you can print out each iteration to see what is it actually checking for. Another thing to print out is values before and after calculations. So maybe having two print statements. So fprintf of all your variables before you do something, and then fprintf variables after you do something. So in here, you would do some sort of calculation. And then any variable that changes values. So anytime you have something that's changing, it's a good idea to print it out if you really are confused about what's happening inside your loop. And then print out your values as a table to easily identify any errors or mistakes. Make sure they're aligned. Just mess with your print statements. You guys saw me do that a little bit. So here's an example code that I have that finds the maximum value in every column of the array. So go through an example. So A looks like this: 10, 1, 7, 4, 3, 6, 6, 9, 2. So here's an example. So in theory, if it's every column, I should get a 10, a 9, and a 7. For some odd reason, I might not be getting those numbers. So here I have nested loops, one to go through all my columns, one to go through all my rows. So it's a 2D array. You don't have to do it this way, but I'm just illustrating a nested loop. So 4 rows, 4 columns. So essentially 4c equals 1 to column. So that means I'm going to go through this column first, then this column, and then this column. So for c equals 1, I'm going to go through this number, this number, this number. And c equals 2, I'm going to go through this number, this number, this number. c equals 3, this number, this number, this number. So maybe just printing out your numbers. Yes, absolutely. Which is why I mentioned for our first sum, go through n equals 0 to 10. Because 10 is a pretty easy set of numbers to digest. It's big enough to see patterns, but small enough to not have to keep scrolling in and out of your command window to see where all your numbers are. Okay, so the goal is absolutely see what's happening every single time you go through the loop, every single time the code hits here, to see what's happening. So Nachev, yes, there's, like I said, in MATLAB, there's a lot of built-in stuff that means we don't have to use loops for basic functions like max, min, sum, all of that. But sometimes we can't avoid it. But these are easy examples to illustrate, so that's why I'm using them to illustrate. But yes, there's the max function that would do this for you. So if you look at what's printed out here, in this print statement, I printed out my value of C, my value of R, printed out my conditional. So here I have a conditional. I'm printing out what exactly is happening here. Printing out, and then my result, my max value. Oops, sorry. So here's an example of printing everything out, and here's my output. You can see what my C values are, my R values are, the result of my conditional, and then what it shows as my max value. And you can start to see, okay, is it behaving the way you think it should behave? Okay, I want to go over some tips for homework 7, just because, like I said, loops are challenging. So with our last 6 minutes, I will go through some tips and ways to recognize why and when you might need a loop. So for problem 1, you're writing 2 functions, one called lower, one called upper. These are very similar. They're just basic examples. They're more similar to your challenge activities, but they're part of your homework. So once again, you're trying to create these matrices. This first one is a matrix where it has a lower triangle of numbers, where each row contains the row number. So once again, start with, okay, so start out with zeros, because it's mostly zeros, just like I did for A, the last example we did. And then one by one, say, okay, A1, I want just one value. For A2, it's 1 through 2. For A3, it's 1 through 3. For A4, it's 1 through 4. So you can start to pick up patterns and create your loop. Keep in mind, this matrix can be any size that you want. So you need to identify for your loops, so for I equals, what do you want your starting value to be? What do you want your increment? It's not always 1. Where do you want to end it? What are you doing inside of here? Some of these might not be hard-coded values. Some of them might be dependent on other things. Same idea for upper. Upper is probably a little bit harder, but same idea. Write it out, come up with a pattern. For problem 2, this is similar to the cube root example I did on Monday. But essentially, you are implementing this algorithm. So your equations are above, that's fine. So it says, use the value for VOC as the first estimate of VMP. Those numbers make sense at the top. But essentially you're just saying VMP equals VOC. This is your initial guess. And then initialize a value for the relative error and the number of iterations. Initialization. This is your initialization of your loop control variables. So choose numbers that make sense. So you have 2 loop control variables for this one, your error and your number of iterations. Okay, so choose numbers that make sense. What do you want your iterations to start at? How are you counting your iterations? What is a good value for your relative error? Does it have to make sense? Is it only used to just get inside the loop? What values are you going to use? And then it says repeat the relative error, repeat until the relative error is greater than, this should say less than, it's corrected in your document. Then a tolerance or the number of iterations is less than 50. So it says repeat. What are you repeating? You're repeating this. Repeat indicates you should use a loop. Okay. What kind of loop? A while loop or a for loop? If it typically says repeat until a given condition, that typically means while loop. Maybe you want to start with a for loop and just do it for a number of iterations to check to make sure your calculation is correct. With these, a lot of them, you start small and you change it and get bigger. Just like we did for the summation problem that I did today. I started with a for loop just to see what the process was, and then I made it a while loop and adjusted as needed. So what are we repeating? This is what goes inside your loop. You're going to calculate your equation given a previous estimate. What is your previous estimate? Well, that's a good question. Initially, it's going to be this. The next time around, it's going to be your previous guess. The next time around, it's the previous guess. The next time around, it's always going to be previous guess. So initially, it's this initial guess, but then your initial guess keeps changing because you have a new guess. Okay. Calculate the relative error. Update the estimate with your newly calculated value. This is the same steps we did for the problem on Monday. And then increment the number of iterations. So I give you, more or less, we've given you a lot of the steps. It's just, you don't have to do it all at once. Start small and add each step as you go along. Keep in mind, what is your stopping condition? When do you want to stop? What does that conditional look like? Which means, is your continuation condition? So when do you want to keep going? These two are opposites or inverses of each other. So identify when you want to stop. What does that conditional look like? How do you know you want to stop? What are you going to compare? And then invert it to get your continuation condition. Keep in mind, when it says the number of iterations is less than 50, I'll change that. It should be less than or equal to, if I think about my solution. So keep in mind the number of iterations depends on how you count it. N equals 0 to 50. If you stop at 50, so if it's n equals 0 to 50, this is 51 values. N equals 1 to 50 is 50 values. Okay, so keep in mind what your starting value is, what your ending value is. Is it less than or equals to? Is it just less than? So for a for loop, counting is pretty straightforward. For a while loop, you have to be a little bit more careful on what your starting value is and then what your ending conditional is. Okay, for this last problem, it says you need to calculate an integral using this equation. So that's just notation. This is your equation. Y1 is the first number in your array. Yn is the last number in your array. Summation. Whenever you see summation, that means you're using a loop. Typically for summations, you use for loops. Not always. You could do it with while loop. What are your values? This is a summation for I equals 2, 4, 6, 8, 10, 12, all the way up to m. Here it's j equals 3, 5, 7, 9, 11, etc., all the way up to m. So these are going to be very basic for loops. You're just summing all of the values inside of your array. Here you're summing your even numbers. Here you're summing your odd numbers. So make sure when you say for I equals, it's the correct numbers. So you want it to be from your starting value. What's your increment going to be? What's your ending value going to be? That's it. So you have your first number in your array. This is a for loop. This is a for loop. This is the last number in your array. And then you just add everything together. So your last line should be I equals h over 3, that's an h, times y1 plus your first sum 1 plus 2 times your sum 2 plus y end. This is your last line in your function. This is calculated with the for loop, this is calculated with the for loop. That's it. It's not as complicated as it looks. And then you'll use your function to do this calculation. Okay. That's it. We are out of time. Hopefully that helps. Come back to this. It's at the end of the lecture. It should help go through your homework. Like I said, this homework tends to be a little more challenging, not in terms of conceptually, just in terms of, okay, I'm seeing this. I know what I need to do on paper. What does it look like in a program? With that, are there any final questions before I jump over to office hours? Okay, I will see all of you guys next week. I will give you more information about the exam in the email on Friday. Like I said, on Monday, best thing to do for the exam is figure out loops, go through the homework, make sure you understand what this process is, because loops are going to come up in your exam. They're going to be very important in your project, so it's really important that you understand loops. No John Cena today. Okay, I got to jump over to office hours. I will see all of you guys next week.